Lesson 112, using sum and difference identities. So the sum identities. Just say that the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. Then you have the cosine of a plus b is equal to the cosine of a times the cosine of b plus the, nope, not plus, just minus, sorry, minus the sine of a times the sine of b. And then the tangent of a plus b equals tangent of a plus the tangent of b, all of that divided by 1 minus tangent of a times the tangent of b. That's the sum identities. Now we have difference identities. So the sine of a minus b is equal to the sine of a times the cosine of b minus the cosine of a times the sine of b. Notice that the sine of a plus b and the sine of a minus b look the same except for that one of them you add, the other one you subtract. The cosine of a minus b equals cosine of a cosine of b, it's going to be the same thing, plus sine of a times sine of b. And then the tangent of a minus b equals tangent of a minus tangent of b divided by, all of that divided by 1 plus tangent of a tangent of b. So if you know the sum identities, the difference identities, exactly the same thing, you just change the signs on all of them, on all the different parts where signs are. We can use these identities to solve problems. For instance, find the exact value, which is not something you're going to plug into your calculator, of sine of 15 degrees. So what you want to do is you want to find a degree measure that you already know the sine and cos of. For instance, 45 and 30. So you could do the sine of 45 minus 30, which is the same thing as sine of 15. So the sine of a difference, so the difference identity, so you take sine of 45 times cosine of 30 minus cosine of 45 times sine of 30. So the sine of 45 we know is root 2 over 2, and the cosine of 30 is root 3 over 2, and the cosine of 45 is root 2 over 2, and the sine of 30 is 1/2. So you multiply and then subtract. So you have the root 6 over 4 minus square root of 2 over 4. So the exact value of sine 15 degrees is square root of 6 minus square root of 2, all of that divided by 4. Another one, find the exact value of sine of 5 pi twelfths. 5 pi twelfths is the same thing as 3 pi fourths minus pi thirds. So we could do sine of 3 pi fourths minus pi thirds. So this is a difference identity. So it's going to be the sine of 3 pi fourths times the cosine of pi thirds minus the cosine of 3 pi fourths times the sine of pi thirds. Then you would look at your unit circle. The sine of 3 pi fourths is root 2 over 2. The cosine of pi thirds is 1/2. The cosine of 3 pi fourths is negative square root of 2 over 2. And the sine of pi thirds is square root of 3 over 2. Then we multiply and we get square root of 2 over 4 plus square root of 6 over 4, which is the same thing as square root of 2 plus the square root of 6 over 4. 10.
At the very beginning, could we change it into degrees? So like multiply by 180 over pi. So change it into degrees if the radians.
Would you get the
doesn't
same
make any sense.
answer? I think you would.
It would be sine.
Because you're just converting.
Yeah.
Here, I'll check.
Okay. I'm going to do one more example with, no, actually, yes, and then we're going to do, why do we have to do rotation matrix? Is that on here? Yep, then we'll do rotation matrices. Okay,
Yummy.
so evaluate tangent of a plus b if the sine of a is 4/5 and a is between 0 and 90 degrees. And cosine of b is 5/13 between 180 and 360.
It's the same, because you get
Okay.
sine of 75, which
Okay.
is just the opposite of sine of 15.
Okay. So, if the sine of a is 4/5, that's the same as y over r. And so the tangent then would be 4 over 3, because this would be a 3/4/5. So the tangent of a would be 4/3, which is y over x. The tangent of b would be negative 12/5. So if the cosine is 5/13, then you know that the sine is 12/13. I mean, it's in the negatives here because of this, where it's at. So the sine over the cos would be negative 12/5. So I don't know if that makes sense where I got that. So
That made
Yeah.
no sense at all.
no sense. Okay, tangent B is sine over cos. And in this 180 to 360, the sine of, wait, it's a 5/12/13. You understand that, right? 5/12/13?
Yeah, it's a.
So the sine would be 12/13, negative 12/13. So you'd have negative 12/13 over 5/13. Just because of where the x value. Oh wait, maybe the cosine would be negative. Because cos is x.
No, the y would be negative.
The y would be negative. Oh,
Yeah,
the y would be negative?
Because it's
Oh, because it's
180
180 to 360. Sorry, I was thinking of the other
So
way.
the y, the sine.
So
would
from
be
180 to 360, all your y's are negative. And sine is y. So the sine would be negative 12/13 over 5/13. 13ths cancel, so the tangent would be negative 12/5. Yes, then you plug it into the equation of tangent of a plus b. So tangent,
Wait,
I'm running out of room, so I'm going to come over here. So tangent a plus b equals, so we have tangent of a, which is 4/3, plus tangent of b, which is negative 12/5, divided by, and then we have 1 minus tangent of a times the tangent of b. So negative, that's
16/5.
going to go to 1, that's going to go to a negative 4. So negative 16/5. So plus, I'll put it like that so you can see. 1 plus 16/5. Which, when you simplify it all down, you'll just get negative 16 over 63. So you would get a common denominator here and here, keep it, change it, flip it, and you'd end up with that. Okay, we're going to do a rotation matrix. Oh, wait, are you still writing? Write faster. See faster. Just kidding. Okay, so we do have to go over using a rotation matrix. Okay, there you go. Okay, so the sum identities for sine and cosine can be used to derive a matrix for rotating a point in a plane. So to rotate a point P, x comma y, through an angle theta, you can use this matrix. It's the cosine theta, and we're doing the first column, so the second row, first column is sine theta. Then the second column would be negative sine theta and cos theta. So if you multiply that times your point xy, you will get x prime, y prime. So you'll get your image. So you rotate your pre-image to get your image. So that's for any degree theta. So if you want to rotate it 45 degrees, you would just use this. That's really helpful, actually. Should have been doing that in geometry. That would have helped a lot. So if we want to do a 60-degree rotation, all rotations are counterclockwise unless specified to go clockwise. So we're going to rotate a quadrilateral A, B, C, D. A is at 0, 6, B is at 0, 12, C is at 3, root 3, 3, and D is at negative 3, root 3, 3. So because it's 60 degrees, we just do cosine of 60 over sine of 60. In the second column, negative sine 60, cosine 60. And then you have to write your point matrix. So you have your A point, your B point, whoops, your C point, and your D point. You can plug it in the calculator and multiply, or you can go across and down, blah, blah. Cosine of 60 and sine of 60 you can find by using your unit circle. Cosine of 60 is 1/2. Sine of 60 is root 3 over 2. And negative sine would be then negative root 3 over 2 times your point matrix. And when you multiply, you get negative 3 root 3 over 3. Negative 6 root 3, 6, 0, 6, negative 6 root 3, negative 3. So your A prime would be negative 3 root 3, comma 3. B prime, negative 6 root 3, comma 6. C prime is 0, 6, and D prime is negative 6 root 3, negative 3. And that would be your rotated quadrilateral. End of the lesson.